So this is parametric, what do we call it? Equations, functions? I don't even know. Parametric functions, I believe. Nope, parametric equations. And we're going to graph these. I'm going to show you real quick how to do it on a calculator. So I've got my TI up here. And we hit mode. And then we go down and we hit parametric. And we quit out of that and go to y equals. And out of that. And I don't like what I have over here. So enter. Let's go down and make it a line. Yeah, should do. And we'll leave it blue. All right, so the first equation is 3 sine of 2t. 3 sine 2. Notice I hit x, I get a t because we're in parametric. And the second one is 1.5 cosine of t. And we hit graph. Now here's the part that I can't hit graph yet. Doesn't say what our parameters are, so it's going to do 0 to t max. I'd rather have 2 pi here. 6.28 is 2 pi. Now I can mess with the step size. I got lots of options. Let's see what happens when I graph it. It does a figure 8. Now it might keep going over itself, but you saw where it started and where it goes, right? So that's it. That's how you graph these things by calculator. I should have shown this in my lesson. I would show it in person, but this works too. So graph here. And looking at the starting point here, came out, ballparking it. Not even close. That's fine. Starting point, or I think I called it initial point, but also terminal point. And let me see if I can figure this out. Plug in 0, we get 0. Plug in 0, we get 1.5. So there's 1.5. 2 pi is going to cycle it through that. A little concerning here. Yeah, it'll cycle it through that. So pretty sure this is 0 to 2 pi for my t, but nobody asked, so I'm not going to say anything. So then it goes there, there, there. Terrible drawing. But hey, what are you going to do? All right. Now, again, I would just use a calculator. So we'll finish this one off over here. Yeah, so this is 0 to t to 2 pi. All right, over here. And by the way, this is where life gets really fun with parametric equations. You do all sorts of weird things. Should be a little more bend on that one here. There we go. And that's our starting point and finishing point. Terminal point. 0 less than equal to t, less than equal to 2 pi, and arrows. Yeah, whatever. I would definitely use my calculator to graph these. There's really no reason whatsoever not to. So. This one is totally bizarre. Lots of tick marks. I am not doing this accurately. I'm just getting it done. I would definitely graph this with my calculator. And it does this weird little there's actually no, oh, there's a bounce here. Bring it down there, which means there should probably be one down on the other side. So this should really be more like this. Something like that, whatever. So we got a starting point and the terminal point, which is weird that it has that in every one. But whatever, we're just learning to graph with our calculator. That'll do. And once again, shocker, 0 less than t less than equal to 2 pi. And this one's even weirder. Well, I guess that's all. Beauty's in the eye of the beholder sort of thing. It does this little missed one of the loops here. Something like that. Yeah. And this is the starting point, terminal point. Really should say initial point, but who cares? And 0 less than equal to t less than equal to 2 pi. I said to show the approximate window size for all of these. I'm not doing it. You can read off the tick marks and go from there. But yeah, that's it. This is a quiz question for me. Just see if you're smart enough to know how to graph things on your calculator. It's pretty easy and wouldn't expect it to be very difficult for anybody. So following problems, parameterization is given for a curve. Graph the curve. Sure. And it goes t is greater than 0 and off we go. And this is the initial point, starting point, because that's what I've been calling it. If you want to call it initial point, there's nothing wrong with that. There is no terminal point. And y equals t, x equals negative root y equals x squared. Clearly when x is less than or equal to 0. Sure, whatever. This one is going to be sideways parabola and negative pi over 2 to pi over 2. So it's got some point here. No, it doesn't have a point because tangent goes forever and ever, and so does secant and pi over 2. So something like that. And also like that, because it goes negative. So the line keeps going. However, the direction is this, and there is no starting or initial point. I'm guessing this is probably a hyperbola, but we'll see. X equals tangent squared t. Where did that come from? Secant squared t minus 1 equals tangent squared t. Y equals tangent t. Therefore, x equals y squared, which is a sideways parabola. It's not a hyperbola. It's a sideways parabola. Yeah, and this should really say, parentheses and all that, but I want you to know that it's the y, so I wrote it differently. Okay. Problems are a bit of a hassle, but that's what you get paid for. All right, parameterization, conversion, all that fun stuff. Okay. So this goes out to 1, up to 1, left. So So this is your starting point, terminal point, x squared plus y squared equals sine squared 2 pi t plus cosine squared 2 pi t, also known as x squared plus y squared equals 1. And we could do this kind of pointless, but sure, whatever. And this goes forever and ever. 2 to 2. Apologize for moving this, but last line I tried to draw like this did not work. And it starts out here at negative infinity and goes up the curve. No starting point or terminal point. X equals 1 minus t. Y equals 1 plus t. T equals y minus 1. X equals 1 minus y minus 1. X equals 1 minus y plus 1. Move y over, move x over. Y equals negative x plus 2. And negative infinity less than x less than infinity. Breaking a sweat here. I am actually breaking a sweat. It's kind of hot in this room. But hey, I'll survive. So this one starts here, goes down to here. So this is the point where people, well, you know that. You've just been graphing things. That's kind of uncool. Okay. Be a whiner, see if I care. Y equals clear, clear. X equals t squared. Big square root 4 minus t squared. Enter, and here's the fun part. I set the parameters. They give me 0 to 2, 2. I can make this a little bit tighter. It's pi over 12 right now, but who cares? Let's just see what happens. Started here, went to there. I don't like that. Let's make this a little bit tighter. Watch what happens when I make it too small, though. Takes its own sweet time, but it looks so much prettier. Anyway, that's how I've been doing that. I mean, I can sit down and write it all out separately, but what's the point? So y equals square root of 4 minus t squared. Straight sub in, x is t squared. Y equals square root of 4 minus x squared, which is y squared, oh boy, minus x. Y equals square root 4 minus x. Interesting. It's a square root curve that's been flipped around and yada yada. 0 less than or equal to x less than or equal to 4. Neat. Oh, nearly forgot. And over here, 1, 2, 3, 4. Third one. And it goes forever. and the arrows that way. Confusion between my arrows and indicating the line goes forever in direction. What are you gonna do? Starting point, no terminal point. X equals t squared minus 3, y equals t, x equals y squared minus 3. Y is less than or equal to 0. If you get something slightly different, do not get hung up on it. It's not that big a deal. Just a little something to get you going. All right, told you how to do this earlier or in the lesson. See if you know what you're doing. It'll roll pretty quick. So I'm going to go with 0 less than or equal to t less than or equal to 1. X equals, weird, a plus bt. We'll go with this being 0. Negative 1 equals a plus b times 0. A equals negative 1. Hey, I got an idea. Why don't we just say b equals negative, not b, a, b, c. C equals negative 3. Why don't we start saving some time now that we're getting good at things? Negative 3 equals negative 1 plus b times 1. B equals, and 1 negative 2. Except that's wrong. That's interesting. I hope I didn't do that in the video. I'll have to check my notes. Have to use that one. 4 equals negative 1. B equals 5. That's upsetting. So x equals negative 1 plus 5t. C equals negative 3. So 1 equals negative 3 plus d times 1. At 3, d equals 4. So y equals negative 3 plus 4t. Just confirmed I didn't screw it up, which is nice. Life's rough. Okay, so a equals negative 1, c equal, whoops, oh, they're the same, almost the same. C equals 3. Therefore, right, 3 equals, notice I think I'm so smart and I just want to run through these problems. I can't. I have to slow down. C equals 4. Over here, negative 2 equals 3 plus d times 1. D equals negative 5. X equals negative 1 plus 4t. Y equals 3 plus negative 5t. 0 less than or equal to t less than or equal to 1. Use any variables you want. I find those work the best. All right, now life gets a little dicey. Let's parameterize some things. Well, I'm just going to throw it up there. I mean, this is kind of lightning bolt math, I call it, where you have to get hit by a lightning bolt to say, oh, that makes sense. Well, I'm just going to say y equals negative square root of t because it's the lower half of the parabola. And then that would make x equal, add the 1 over, 1 plus square that t. Okay, sure. And then 0 is less than or equal to t is less than or equal to infinity. I can quite guarantee you I did not figure this one out. I stole it from the answer key somewhere. There's lots of other solutions. That's just one way to do it. You just say y equals t and run with it from there. I mean, it doesn't really matter. This one works. Left half the parameter. So here we go. There's a little more typical. X equals t. Therefore, y equals t squared plus 2t. Sure, what the hell, why not? And then I want the left half, so I play with this a little bit. Negative infinity less than t less than or equal to -1. Okay. And of course, as I noted earlier, lots of other solutions with exclamation points even. All right, here's a quiz question. Boy, do people die on this one, and I don't really understand why. They don't realize that when I capitalize something, I'm desperately trying to help them. Whatever. So -5, 3 minus -5, 5, 3 minus 5 is -2. Ding, ding. -5 minus 1, brain cramp. Very disappointing. -2, -6. Right about here. Okay. Now, when x equals 0, -3 equals -t, 3 equals t. T could be either 3 or -3. All right. Let's go with -3 since starting -5. And you're probably like, what the hell just happened? Trust me on this one. I would just slap some points in there, but I'm trying to be a little smarter than that. -3 minus 1 is -4. 1, 2, 3, 4. So it's going to hit here. Because when I put in -3, 3 minus 3 is 0. Yeah, that makes sense. So this is t equals -5. I'm not going to keep drawing them in. I'm going to say at 0 with the absolute value, things flip-flop. So 0 is 3 and -1. 1, 2, 3 and -1. T equals 0. Straightish line with arrows. Okay, then what happens? Well, now it's going to bounce back because the slope's going to change. Let's go with 1. 3 minus 1, 2. X equals 1, 2. 1 minus 1, 0. Ooh, it's going to hit right there. And then let's go with 5. 3 minus 5 is -2. Boy, that sounds familiar. And 5 minus 1 is 4. 1, 2, 3, 4. Got to turn the page. Apologize for those who makes their brains hurt. So this is t equals 5. So I believe the quiz question is, when is it in the second quadrant? And you would say, okay, well, when does x equal 0? And that would be at 3. So it's from 3 to 5, not including 3. So this is not a question here. It's something trying to prep you for the test. 3 less than t less than or equal to 5. So that would be that. But for you guys, there it is. It's graphed, and I slapped some numbers on there just to help you out. Oh, I forgot my arrows. So disappointing, and I do love drawing arrows. Yeah, so that's a quiz question. You'll see it soon. A lot of people bomb it. I don't know why. It's pretty easy to me. Find the values of t that produce a portion of the graph that is in quadrant 1. Holy cow, like I thought this was coming. Wow, that's crazy. Now, so let's just cross that out. Go down here. So Q1, 1 less than t less than 3, because that's on the, whatchamacallit, sorry, that's on the quadrantal. Bet you didn't think I'd remember that. Scary. Hey, we already did this. Yeah, but I put it in the right spot this time. And the third quadrant can be -5 less than or equal to t less than -3, and quadrants. Is that right? Quadros? Man, I really gotta learn my languages. t is less than 1. Pretty cool. Okay, hopefully you know what that just happened. Find a resolution for part of the graph in quadrant 1. That's kind of a hassle. Let's keep it simple. X equals t, y equals t squared plus 2t plus 2. And then we just play with this, even graph it on the calculator until we get what we want. Same thing over here. X equals t, y equals square root of t plus 3, 0 less than t less than infinity. And you just plug it in and see what happens. It gives it to you. Ooh, neat. I like this problem. Wish I could get one more focus here. I could zoom in, but I really like the way the picture works. I'm going to screw around with this. So I'm not going to screw around with this. I'm just going to go with x equals a cosine of t. And I like having x and cosine match up because you could really do this a lot of different ways. And we all know that x squared plus y squared equals a squared times cosine of squared of t plus, you know what, I'll just factor out the a squared, sine squared of t 1. And so we get x squared plus y squared equals a squared. Yay, but we want to start at a0. So we want to start when this is equal to a, so that's at 0. All right. Oh, for goodness sakes, I don't have this. I'm not going to trace a circle as indicated. All right, so I like to say that cosine of 0 equals 1 and sine of 0 equals 0, just as a reminder. All right, so one's clockwise. Clockwise, start at a comma 0. So we're starting at and well, cosine was we start at 0. I'm going clockwise. That's counterclockwise. So this is the wrong way. That's the typical way. Why did I put little ones here? No idea. So we want it to go the other way. So let's just slap a negative in front of the y. X is not going to change. And again, there's lots of different ways you can do this. This is as simple as anything I can think of off the top of my head. And we'll just go from 0 to 2 pi. Now counterclockwise, we already had that kind of set up. X equals a cosine of t, y equals a sine of t, 0 less than or equal to t less than or equal to 2 pi. And then clockwise, that's the first one. X equals a cosine of t, y equals negative a sine of t, 0 less than or equal to t less than or equal to 4 pi. Cool stuff. Cool stuff. All right. I'm going to slap these together because you're going to get bored really fast. So let's just keep it simple. X equals negative a cosine of t, negative a0. So starts at the other side. Let's look at my graph up top. So I'm not making another one. And then b sine of t. Oh, this is a ellipsy thingy. And the negative just helps me organize things. X squared over a squared plus y squared over b squared equals, interesting, negative a squared cosine squared t over a squared, see ya, plus b squared sine squared t over b squared equals 1. Sure, whatever you say. So we've been here. x equals negative a cosine of t, y equals b sine of t, 0 less than equal to t less than equal to 2 pi. And by the way, you're probably like, I'm just following along. I have no idea what's happening. You really have to put this in a calculator and see if you can figure out what's going on, because otherwise it's kind of pointless. But at the same time, this is just practice, try and make you handy with parameterization. It's really not that critical that you can do this. I just want you to get the general idea, starting point, ending point, so you understand what parameterization is. Oof. Oh, that is very tiring. Yeah, but parametric, we needed the extra practice, make sure we know what we're doing. So happy mathing.